Good morning, everyone. My name is Dr. Shelley Henderson. I'm a medical physicist working up in Ninewells Hospital in Dundee. I've been asked on behalf of NEST to talk to you this morning about AI's impact on your healthcare science training journey. Apologies I can't be with you this morning, but I do have my email address at the end of this presentation, so if there's anything you want to contact me about, please do feel free to get in touch. This is just an overview of what I'm going to be talking about this morning. So starting off, just an overview of what artificial intelligence and machine learning is and how it works in practice, the advantages and disadvantages of it, and then we'll touch upon how it might be of use within your training setting. Artificial intelligence and machine learning tend to be terms that are used interchangeably, but artificial intelligence is really the capability of a machine to imitate human behaviour, and it incorporates a number of different technologies within that umbrella. So machine learning and deep learning, expert systems, natural language processing and robotics. Machine learning is a specific approach within AI in order to enable machines to learn, and it uses algorithms and can learn from large data sets without explicit programming. I think we all tend to think of AI as being a new concept, but it's not new at all. It's been around since the late 1950s, and neither has it become more intelligent. The only factors that make it more prevalent in today's society is really that there's more computing power available to us, and we have more readily accessible data than ever before in order to be programming and using these algorithms in our day-to-day life. To the number of people that always say I'll never use that, thinking particularly of my own older relatives, AI is already in use in our day-to-day life, and you will be using it whether you realise or not, whether it's predictive text on a mobile phone or when Google makes a suggestion for you of what you may wish to search for, chatbots from a lot of the large retailers and online retailers. Streaming services for both music and film produce their recommended items for you based on your own demographics and previously viewed or listened to material. Social media is a big user of AI, and it uses AI to display adverts, describe how it's displayed to you, and also suggested friends based on facial recognition from photos that you upload. Banking, again, has been using AI for a long time in order to identify what's normal behaviour for you, whether you tend to use card, cash, PayPal, ATMs, and it also uses your positional information in order to try and keep your money as safe as possible. And device security, it's reasonably standard now that a mobile phone or a laptop comes with either fingerprint ID or facial recognition to keep your device as secure as possible. And Canva and Microsoft Office design features also use AI in order to try and produce PowerPoint presentations that are likely to be relevant to yourself, just like hopefully this one is. I am not a computer scientist, so I don't pretend to be an expert in how AI works in practice, but I think a basic understanding of the process is pretty important, especially when it comes to how you decide how you're going to use it. So all AI starts with training data, which comes from huge data sets, which should come from a wide variety of sources. The more data that's in your training data sets, the better your AI algorithms will be. Those data sets need to be comprehensive. They need to include as much information as possible, and they should also be inclusive and unbiased. So they should have data from a wide variety of underlying cohorts to make sure that data is accurately represented. All of this training data is fed into a neural network, which is a way that computers try to mimic the way the brain operates. So they produce algorithms in order to establish mathematical relationships between pieces of data, and it works with probabilities in order to classify the data, and I'll speak about these a little bit more on the next slide. And we finally use test data. So this is done both by the computer programmers and also by yourself when you're using AI algorithms. The test data is unseen data, and it's really important to have this within both the training stage and also to use it when it's being used in earnest, really. And this is because it validates the functionality, performance and security of the AI. What most AI computer programmers do now is they then also use any data that's input by users, so ourselves. They use it as a feedback loop, so it's then reutilised as training data in order to improve the operation of that algorithm. Neural networks are hugely complicated mathematical things, so I'm not planning on going into it in any detail, but this will just give you a broad overview of how the algorithms work in practice. When you use an AI algorithm, your input parameters are given key features by the algorithm itself. So it will identify either key pixels within an image, or it will identify keywords within a sentence. A window is then placed around those key parameters in order to give context, and that's why there's a number of input nodes in this neural network. All of those input parameters, both the key parameters and the context ones, are fed into the neural network. The neural network is simply lots of interconnected nodes. So the node tends to be connected to several nodes in the layer beneath it where it's receiving data, and it feeds the data output onto the next nodes in the level above it. Each node's assigned a weight for each connection. So here I've actually labelled the nodes with weightings, but that's more for tidiness value than anything else. Each of the individual connections feeding into that node would be assigned a weight. And similarly, each individual connection also has a threshold. The data that's fed in, multiplied by the weighting associated with that connection, has to exceed the threshold before the data is passed on to the next layer. And then the process is repeated through all the hidden layers within that AI algorithm. So the number of hidden layers is how much processing the AI algorithm is actually doing, and deep learning is directly related to the number of hidden layers. All of the weights and thresholds are determined during the training phase, and they're continuously adjusted. So they're continuously adjusted until all the training data at the output nodes are consistently and accurately labelled relative to the input nodes. And they are also continuously adjusted while test data is being input as well. The downsides on AI tend to relate mostly to what data has been used to train the algorithms. AI will always perpetuate stereotypes and bias, and there's a very famous example of Amazon using AI to filter out CV applications for position for higher management within their service in the US. Because a lot of these positions tend to be occupied by middle-class, middle-aged white men, it filtered out all of the applications that didn't meet that criteria. Now, that's not a fault of the AI per se. The AI was simply operating on what data was already within its data bank. However, the user should have been aware as that being a limitation of the AI algorithm because of that bias. So AI cannot think, and it can't evaluate or innovate, and it tends to be pretty poor with technical language, but that may change over time. It doesn't always recognise it, and it doesn't use it particularly relevantly in outputs neither. There is the opportunity to ask large language models for peer-reviewed publication references. However, be aware that they may be irrelevant, and sometimes they aren't even real. It can make them up. The responses from AI tend to be quite wordy, and that's because it tends to feed back most of the information it can find on the query that you have given it, and it's usually referred to as word soup. It also might not always directly answer the question that you've asked it. For example, a typical example is if you ask it to compare two different things, it will describe each of those two things individually but won't actually do a comparison for you. If you ask it to limit the number of words it's using, which you can easily do, it reduces the relevance of the responses. So again, it's something to be aware of. It's affected by any rogue data, poor input data quality, or unusual cases where perhaps it's not conforming to anything stored within its data bank, and it also can't do anything with cases that require some form of expert interpretation. And the other thing to be aware of is it isn't always repeatable. It won't always give you the same answer. However, I'm not here to talk about the negative side to AI. It's a very powerful tool, and we really want to be harnessing its use if we can. Where it's very, very powerful is it can simplify repetitive tasks that don't require any expert knowledge. So it can remove experience dependence for some things like, for example, perhaps processing a sample or segmenting an image. However, it can't remove the need for an experienced person to be part of that process, either whether it's validating what results are coming out of it or being able to interpret anything that is involved in that process. So it can speed up some processes and it can analyse vast data sets, which may assist in decision making or detecting trends that might just not be possible if you were using more manual methods. Where we want to go with healthcare science is we want to try and introduce AI where we can in order to lead to more personalised healthcare. Currently, all patients with a specific condition tend to be treated the same, and that's partially due to resources, but it's also partially due to not being able to personalise healthcare because of the lack of information on what works and what doesn't. So by looking at huge data sets, hopefully we can work towards personalising healthcare to improve the patient pathway for patients and improve their outcomes. So let's move on to talk about AI in your healthcare science pathway. Be using AI in your training. I don't think I can give you a definitive answer, but I think there's a nice parallel here with the concern that the educational community had around about 25 years ago, which was should you Google the answer to a question? The answer to that is it depends what for. If you ask Google, I have a sore throat, what could be wrong? One of the answers it will give you is that you have esophageal cancer. How likely is that? And that's really where us as healthcare scientists are particularly placed to be able to use AI effectively. We understand that you shouldn't just take an answer as read, and we tend to question things. So although AI can assist in many aspects of healthcare, it can't replace us as the experts in the field. As part of our training, we're taught to understand what we're doing, the what we're doing, the why of we're doing, so we can identify when things don't work, how we might rectify it. Or when we come across an unusual case, what we may be able to do to still deal with that specific case. We also know what we don't know, and we know to question things. So we are perfectly comfortable saying, as healthcare scientists, I don't know the answer to that, but I know how to go about finding it, or I know how to figure things out. And I think that's again leading back to do not take anybody's answer, particularly when it comes directly out of a computer. Be comfortable questioning it. And the other thing is we're scientists. We innovate. We don't want to be doing the same job day in, day out for the next perhaps 40 years, the rest of our career. We want to push things forward. We want to change things. We want to make things better and more efficient. And that is why we still have a very important place. But we should be using all the tools available to us to assist us in that journey. And AI is going to be one of them. Obviously, you cannot use it to write up CBDs or pieces of work for a portfolio. It's plagiarism if you get somebody else to write something for you. But also these things are very personal to your own situation, and you should use the opportunity in order to describe your training examples within case-based discussions and your wider portfolio. If you do use it, acknowledge when it's used. It's important that we understand what we're using and when we're using it. So do acknowledge if you're using it. And use it to demonstrate your understanding of processes within your own section. The Science Council tells us that a scientist is someone who systematically gathers and uses research and evidence to make hypotheses and test them. AI cannot do that, so AI cannot replace our expertise as scientists. It can't innovate, interpret, or problem solve, and I think this example here sums it up really nicely. If you ask AI to say drink and say it 10 times, it will just parrot back the information 10 times. AI is a parrot. It's a very fancy parrot. It's a very powerful parrot, but it is just a parrot. It can only give you information that it already has within its data bank. But there's lots of ways you can constructively use it. You can compare it and evaluate it against what was being done before the introduction of AI within your department. You can compare it with what was previously reported in the literature, perhaps things that your supervisors would have done way back when they were training. Challenge it, push it to its absolute limit, see if you can break it, see if you can find where it fails, see if you can find the absolute limit of what it can do. And also consider where AI technology could be useful. where it may not already be in use within your department, or it could never be of use as it currently stands. So I have a little bit of a formula here that I think is quite useful if you're wanting to evaluate AI within your department. However, again, I have to reiterate, you're a scientist, you'll have your own way of doing this, and please do use it. But if you're using AI, think about how it has been trained. Where does the origin of the data come from? Is it representative of what you're using it for? Do you know the size of the training data set? Was it sufficient to cover every eventuality? Are there any biases in it? Will it work in every situation? Is it representative for the demographics of the patients you're using it for example? Obviously, repeatability is so important. Is it going to perform the same every time? If you don't have a repeatable method, it's never going to be of use in a clinical service. What is it replacing? What were the old methods? Was it a completely manual method? Was it something else different operated? Did it have lots of different steps to it? Were they repeatable? Were they free from bias? And really think about how the new techniques compare with the old techniques. And finally, is it a step forward? Is it making things better for the patient? If it's not going to save time for us to be doing something different, if it's not going to improve accuracy, is it really going to have an impact for the patient as the end user? I've got a very brief example here I'll quickly talk through. I'm an MRI physicist by trade, and one of the things we do is we do flow quantification on cardiac MRI images. So in the centre there, you have just the aortic valve opening and closing. This image is made up of 25 static images, and in order to assess the flow coming out from that area, we have to perform a segmentation of the aorta on both the magnitude and the phase image to measure what is called the cardiac output, which is a measure of the aortic valve function and also the left ventricular function. The software that we use currently has a manual method. So I say manual, it's semi-automated, but using a circle tool where we draw contours on each of those 25 images, or it has a one-click segmentation where it analyses those 25 images automatically. The one-click segmentation takes around 2 to 3 seconds. The semi-automated method is anything between a minute and a minute and a half per patient. So for this talk, I just quickly used the semi-automated method 5 times and the fully automated AI method 5 times, and these were the results that came out the other end. So you can see that the error on the one-click method is about 0.5%, and the error on the semi-automated method is about 1%. And the difference between these two cardiac outputs that are measured is around about 3%. So up until now, everything's reasonably automated, and I could feed these results into an AI algorithm. However, it would not be able to tell me if that was an acceptable end result. Only you as the expert and whichever respective clinical professional you're working with can decide what level of error are you happy accepting. Can you evaluate its significance and what it would mean for your own patients? And that's what I mean by really thinking about how you can challenge AI within your own working practices. And here I have a very good paper. I really recommend you use it. You have a look at it. It's how AI is already currently being used within the lung community for looking for early screening for lung cancer. And it's using information from every aspect of the patient's pathway to feed in to try and improve the diagnosis for them. So healthcare scientists versus AI. AI, there's no denying it's powerful and it's fast and it can automate methods. However, healthcare scientists still have the edge. We're capable of complex problem solving, creative thinking, and we can make decisions based on the wider context. We have a high level of intelligence, both emotional and intellectual. So I think really we have to remember that we have to work together in order to be able to move healthcare forward. We want to be able to implement AI within the healthcare setting in the best possible way. I just want to finish with some final thoughts. I think there's a real feeling by many that AI is not a good thing, that it will make us all redundant, that it will dumb us all down because we no longer have to think about things, and we no longer have to know things. So I want to keep it really topical and relevant and talk about back in the 1760s, the start of the Industrial Revolution. Everybody then thought they'd be out of a job because machinery was taking over, but there was so many improvements in daily life. There was more accessible and affordable goods. It improved our infrastructure, quality of life. It also led to the rise of specialist professions like ourselves. The real thing relevant to us is it started the rapid evolution of medicine. High quality equipment production meant that medical supplies could be made quicker and to a higher quality. There was another revolution in the late 1970s, which was the computer revolution. And again, there was a real cry of people worried about their jobs. Again, it has led to improved communication, increased efficiency, better access to education and information. And I think we can all easily agree that the medical advancements are beyond belief. You know, digital imaging, electronic patient records, computer networks to allow transfer of data between different departments, different hospitals. And I think that's really something to bear in mind with the AI revolution that's currently happening. It can have a lot of advantages, and hopefully it very much will for the healthcare sector. Our jobs as healthcare scientists, I think, are to make sure that AI is implemented, it's implemented and used correctly, and that we're there to support that transition and see where the future is going to take us. If I've got it all wrong and the robots do take over, from what I gather, there will still be a place for us, as was discovered in 2011 when the AI engineers created an Android robot. So thank you very much for listening. If you have any questions, as I said at the beginning, please do feel free to contact me. Again, I'm sorry I can't be there, but I hope you enjoy the rest of your day.